Today, as part of my practical B2 training on Airbus A320, we need to perform a leak test of the principal static and total air data system. And as always, I would like to show you how to do that. So let's take a look at it. And what are these systems good for? Well, they are here to tell airplane how fast it flies, which means it will give us true airspeed, and how high it is above the ground, which means true air altitude. And all this is possible only thanks to pressure, air pressure to be exact. And this information is provided thanks to 3 pitot probes, which you can see over there. That's 1, 3, and 2. Then static ports for each system. We have 2, so these are standby on the front, and then we have 2 static ports on each side for captain and first officer system. And what is their function? Pitot probes provide total air pressure, which is important for the speed, and static ports provide static pressure, which actually gives us information about altitude. And why we have everything 3 times on this airplane? Well, the answer for this is that we have 3 independent systems, which are called ADIRS, or Air Data and Inertial Reference Systems. These systems are here to calculate your speed, your altitude, and inertial reference is here to calculate attitude. This system requires few more informations, like temperature, which is provided by total air temperature sensors, and angle of attack sensors, which you can see up there. They measure the angle of attack of the airplane. And as well, inside you can find accelerometers and gyroscopes, which helps, of course, to calculate attitude. Okay, and how it works? Pitot probes and static ports are here basically only to guide air or provide pressure for the sensors. And sensors are your translators. They transfer the information, which is pressure, to digital signal. And this all is happened in the component which is called Air Data Module. And each of ports, which you can see out there, has one. These air data modules you can find very close to the probes, but they are inside of the airplane. Like in this case, this is aft avionic bay. Behind me you can see racks with most of the computers, and the static ports, which I showed you from the outside. These are the left ones here, and air data modules are directly above them. These 2 devices are only for these 2 static ports, and they translate actually the information which is provided by pressure or the air pressure to the computers. And the computers which need this information you can find down here. This is ADIRS 1, here is 2, and here is number 3. As I said before, each air data module provide information to its own ADIRS. In case of those 2, which I showed you over there on the left side of the airplane, you have captain and FO, which means captain to ADIRS 1 and FO to ADIRS 2. Here behind me, you can see air data modules from the right side. And now let's take a look on the one which belongs to pitot probes. Here you can see pitot probe which belongs to ADIRS 1 or to the captain. And this one is standby, or it belongs to system number 3. And here you can see the probes, or the connection to the probes, and air data modules are up here. So those 2 modules transfer again informations to ADIRS. And by the way, each of these probes is equipped with a heating system, and this way will avoid buildup of the ice. And today we're gonna talk about pitot probes and static ports for system 1 and 2, which is for first officer and captain. And yeah, this is what we need. We need to test if there is no leak on the system. And since you know more or less all basic information, we can start with the procedure. And first task is pulling out all the CBs. And for this procedure, we need to pull CBs for a heating system of all probes.
Which are these now?
Huh?
Which are these now?
These are probes, all the probes, because we might, since we maybe put the airplane in the air, this will start heating immediately. Or if you pull LGCIU, it also trigger the heating. But we'll see in the rest of the test. And the computer. If you pull the computer first, it will start heating. So you need to pull the probes first, and then you can pull the computer.
Hey, there's a row.
Yeah. And a few more CVs are remaining. All CVs are pulled, so we can go out and start with the preparations.
First you put it here and here. Huh? Wait.
Waiting.
You have to try to do it in the same time. Yeah, little bit. Then you adjust it. And then here you can also adjust the
probe itself.
Exactly on this one, yeah? On the hole. Yeah. And then you attach it like this, and then from here. Yeah.
And by the way, this is equipment which will create seal connection between testing equipment and the static ports.
Multi-purpose.
We'll just we should wait. Yeah, we are now on the probes, static ports. As the next, we need to install testing equipment also on both pitot probes, but before that we need to make inspection if there is no contamination inside of the pitot probe. So we need to go all the way on the static hole, right?
Yeah, and then it should be gently. There's a second seal. If you try to force it, you can damage the inside seal. Yeah, so at some point now it stops, and then you have to, adjust it a little bit. Yeah. And then it goes inside. Yeah. Then you start inside from it.
Yes.
Okay. Okay. Now. Yes, that's it. Okay, and now you not this way. It's this way. Yeah. Yes, tighten it. It should be tight.
Singing.
Yes. Okay. Perfect. Wow. The cables, the hoses. Yeah. They are normally labeled. Yeah. So this is standby static left hand. We don't need this.
This is static main left hand.
Static main left hand. Yes. So. Okay. So you remove this one. Yeah. Yeah. And you remove.
Okay.
And then when you insert this, you also hold it from this side. And should click. Yeah. And you carefully insert it because you can damage the pin. So this is from the other side. Just put it in and then it will click, okay?
Okay.
When you say it, it's just, I don't know.
Yes, that's
like. No, really, I do, but it's fine.
I want to do this.
Yeah. So now we connect it here.
You can do that.
Yeah.
It's clean.
Yeah. Okay.
The other side. Push it. Yeah, push it. Yes.
Static and pitot, eh? So the pitot is the small one, the static is a bigger one, so you don't mix it. Yeah. So here is the pitot, and you check that it's the pitot, and then click. Yes, that's it. And you see, this is the bigger one, so you cannot install it here. You can try. So static. 1, 2, 3, 4, 5 static, 3 pitot.
What are the rest of the connections for?
For
For
other
standby.
things, if you want to connect, you can connect each system, different system. Eh?
This angle of attack and need to be,
Yeah, from normal you put it up, which we did.
which we did, yes. Very good. ADIRUs on.
Okay, so on the FIS, set the barometric pressure to 1013
Set.
hectopascals.
Set.
Yeah. Or you pull it to standard.
Okay. Standard.
Now we have to go down, and on the pressure generator we will put some pressure, and then when we put this pressure we should have on the captain and first officer PFD 20,000 feet plus or minus 40 and airspeed from 320 knots.
So since we're testing the main system, the captain and first officer pitot probes are plugged, and as well static ports on right side and on the left side. We need to be connected to the system. The part which we're not testing today is a standby system. This is standby pitot probe and standby static ports, which you can see over there and over there. So only main system.
Okay, control. And now, not what I normally do, I go here to units, and then because here you need hectopascal, so I go here and then I change it to hectopascal, okay? And the altitude I change to 3000. This is the rate that you will go from 0 to 3000 for 1 minute. The maximum is 6,000 feet per minute, yeah?
Ah, okay.
I do it for 3,000. Yeah? So, then we go to control. Okay, and now we have feet, altitude, airspeed, yeah? 3,000 per minute. This is altitude in feet and knots, and this is the pressure. Yeah? So now we go to, let's say, 2,000 feet with 50 knots.
And now it's simulated.
This is the command and this is the simulated, right? Yeah.
That's quick.
So I will quickly go upstairs to see.
Okay, and here you can see speed, 50 knots, and 2,000 feet of the altitude. And same on the first officer side.
30, 20,000, 320. But here in the manual they say set the static pressure to 455.4 hectopascal. That's why I changed it here to hectopascal. And now we'll go here and we'll put this one 455.4. Okay, enter. And for the other one, it will be 641.8. This is for the speed, the total pressure. Static pressure is the altitude, and total pressure is the speed. Okay, so now we are in this configuration. Yeah. So now when we go up, we should see if this is the exact values. Yeah?
It looks beautiful.
Now what I do is you can put the speed to, but this is just fun from me, okay? So 320.
Yes.
And we have 20,000 and 20,000.
And you have target set.
Yeah, so I write it here, let's say captain and first officer. And then I write 20,000 feet, 320 knots. Okay. Now I will press the leak. Yeah. I will press the leak, and in 5 minutes, after 5 minutes, we will check the altitude.
Yeah.
And after 10 minutes, we'll check the speed.
Okay. So now you press the leak.
Yeah.
And now it should hold. It's 41.
Yes, and now we can stay upstairs
And observe. Okay, so after 5 minutes we dropped like 2 knots from the speed, and let's say 160 feet from the altitude, which is in limit. So leak check for 5-minute pass.
you have tests where you have to go for 40,000 feet. Yeah, so if you have a leak and it drops immediately, you have to change probably the air data mode. But
So basically we need to always follow the exact pressure which you have in the manual, otherwise you're not gonna get exact data.
in some manuals they give you in feet, but they give you, let's say, 20,400 and something.
Okay.
Put here, so you get to 20,000.
20,000. Okay.
But when it's with pressure, I always do it with pressure.
Makes sense, and it was nicely
Because when
shown.
you put this pressure here, and you get this one here, this means that the air data module is okay.
Okay.
When I put here 20,000, it's not 20,000 upstairs.
Yeah, because the pressure
leak-
is not correct.
The leak is okay. But when I put the pressure, I know that also the air data module is okay.
So when you press the vent, you release the.
Close to ambient. But I did it.
Yeah, I saw. So you release the pressure step by step. And since test pass, we can slowly start to remove all equipment. Yes. There is one more CB which we pull inside of the right avionic bay. That one is to prevent deployment of the RAT if during the test we're gonna lose electricity. Because since we are reproducing a flight and we will suddenly lose the electricity, it will automatically deploy the RAT. But we want to avoid this, so as a prevention, we pull one more CB. And as a last thing, we will close all the CBs which we pulled before the test. And as well, we put angle of attack probe back to normal position. Well, I hope you have now an idea how the airplane knows how fast it flies and how high it is above the ground. Big thanks to my colleague for sharing all this information. And of course, I need to respect his wish, and that's that he don't want to reveal his face. He's right. So I can only say thank you for telling us all this information. As always, guys, I would like to ask you to don't use this as a replacement for your maintenance manual, but always use latest documentation released by manufacturer. Big thanks Austrian Airlines that they let me record all these videos for you. A big thanks to each and everybody who's watching my videos, and especially to members. That's all from my side. My name is Tomáš, this was Aircraft Maintenance with Zeto, and I will see you on next video. Bye.